If you're preparing for NEET, mastering the 3 equations of motion is absolutely essential. These equations are the backbone of kinematics, and you'll see them pop up in all sorts of physics questions, whether it's about cars speeding up, balls being thrown, or rockets launching into the sky. Understanding them not only helps you solve direct problems, but also builds your confidence for tackling more complex concepts later on. The best part? They're actually pretty straightforward once you get the hang of them. These formulas are powerful tools that can unlock a huge variety of problems, saving you time and effort during the exam. With just a little practice, you'll be able to apply them almost automatically. Let's break them down step by step so you can see exactly how and when to use each one. First, what do we mean by equations of motion? These equations connect 5 crucial quantities: displacement, initial velocity, final velocity, acceleration, and time. Whenever an object moves with a steady, unchanging acceleration, like a car picking up speed on a straight road or a runner sprinting off the blocks, these formulas let you predict what happens next. Here's the cool part. If you know any 3 of these 5 values, you can use the equations to find the other 2. Let's start with equation 1, which is often written as v equals sine u plus at. This equation tells you the final speed of an object after a certain amount of time, given its starting speed and how quickly it's accelerating. It's perfect for questions where you're tracking how fast something gets after speeding up or slowing down for a set period. Use it when you know the initial speed, the acceleration, and the time interval. For example, if a runner starts at 0 m/s and accelerates at 3 ms2 for 4 seconds, you can quickly find their final speed. Let's try a classic example. A car starts at 10 m/s, accelerates at 2 ms2 for 5 seconds. Plug those numbers into the formula, and you get a final speed of 20 m/s. Simple, right? Now, on to equation 2. Equation 2 helps you figure out how far something travels during that time. It's written as ES equals sine ut plus 1 hat to at2. This is super useful for questions about distance covered while accelerating. Using the same car example, starting at 10 m/s, accelerating at 2 ms2 for 5 seconds, you'll find it covers 75 meters. This formula is a lifesaver for questions about journeys, races, or anything involving distance. Now, what if you don't know the time, but you have the initial and final speeds, acceleration, and distance? That's where equation 3 comes in. v2 equals sine u2 plus 2 as. This is your go-to formula for linking speed and distance directly, without needing to know how long the motion took. It's especially handy for problems where time isn't given or is hard to find. For example, imagine a bike starts at 5 m/s and accelerates at 2 ms2 over a distance of 100 meters. You can use equation 3 to find the final speed at the end of that stretch. No stopwatch needed. Here's a crucial tip. These equations only work